Hello everyone, thank you very much for joining this live event, lesson 4 from the Spring Reactive series, and we finally go inside the box, and today we are going to discuss the architecture of the main components, the main contracts that we've been using in the previous 3 lessons, but on purpose I didn't go in detail. So I just started very practically showing you how to build an app, endpoint to the database. We discussed routes. We even discussed consuming and managing errors in case of consuming a reactive route. But we didn't go into Flux, Mono, subscribers, and I'm pretty sure that there are a lot of things that are not necessarily clear for you because we only saw everything from the surface. So it's time to go inside the box and see how the mechanism works behind the scenes, and that will reveal a lot of things that you need to know and will make you understand much better what reactive is. If you're watching the event live, of course, don't forget that we have a live chat there, so you can ask questions and start discussions in the live chat directly. If you're watching the event recorded, I'm still looking forward to your questions in the comment section, or of course follow me on LinkedIn or Twitter and we can discuss there as well. So that being said, again, today's lesson is a bit more complicated. We won't see only things from the surface anymore. We are going inside the box and discuss things that we saw in the previous lessons, but we didn't have the chance to understand how they were behind the scenes. And to do that, I would like first to start with a diagram. So let me draw together with you a visual and understand which are these contracts that we will be talking about, and then we are going to build an example to prove exactly the communication between these two. And I'm totally sure that we won't have time today to cover everything, because as you will see, there are plenty of things to discuss, but that's why we don't have a limitation in the number of lessons. So next time it's a next lesson, and we are going to continue with everything that we didn't have time for today. So let's first say that in case of a reactive application, you have values that we treat as events, and we already saw that, and we focused a lot in the previous lessons on the concept of an event, because you've seen that one of the nice things we can do when we have a reactive application is that we can treat things as events and publish them from one app to another, and including the front end here if that's the case, without needing first to process everything. So you can treat everything like a pipeline of events, and that's what we called Flux, and we used this Flux. Why didn't we use a list in terms of a non-reactive application? You would have had a list, and what's inside would have been the content that you deliver. You have a list of 10 products, you process everything, you send everything to whoever consumes it. In terms of a reactive application, you already saw in the previous lessons that that's not necessarily the case. You can have 10 products, but instead of thinking them as products, if you process them and the processing takes time, you can process the first product, deliver it, process the second product, deliver it, and so on and so forth. And that's why we say that we have this kind of a manager of the events, that's creating the events. Someone has to create the events. Who is creating the events in case of a reactive application where we have a publisher? A publisher creates the events, and what you will see is that both Mono and Flux are publishers. So we will refer to them either as publishers or simply as Mono and Flux. And it's a very small difference between Mono and Flux, because you just can think about Mono as being a publisher of only one event. It's always 0 or 1. And to a Flux as a publisher of 0 or multiple events. So the difference between Mono and Flux is that Mono will always have max one event, and the Flux will have, well, a larger number of events. An indefinite number of events can flow through the Flux. Of course, you might wonder, why do we have both of them? Wasn't Flux enough? And then why do we still need Mono? But that's an easy question to answer, because if you think about just a normal application, a non-reactive one, when you create an endpoint that needs to return a product, you don't create the endpoint to return a list of products and return a list with only one product, isn't it? You either return directly the product type or an optional of product, depending on how you create your application. That doesn't matter, but the idea is that you feel the need of making this difference. And that's the same case here. You will feel the need of making the difference between one and multiple, and that's why we have Mono and Flux, and we don't only have Flux. But in deep down in their implementation, you will see that they are the same kind of thing, that kind of thing that we will call a publisher. And the publisher is the creator of the events. That's where the events come from, in a flow of events of a reactive application. So that being said, let's say this rectangle here is our publisher, and then whatever you always have, and I will explain immediately why, because it's whatever you always have but you didn't see in the previous lessons, and I'll explain also why you didn't see that, is a subscriber. So the subscriber registers to a publisher and consumes values from the publisher. And I will make a very strong point here. When I say consumes from the publisher, it literally asks for the event, and that's something really important that we will call back pressure. But let's come to that a little bit later. So the subscriber, which needs to exist, consumes the events that are generated by a publisher, a Mono or a Flux. And there is also another object that we need to understand and creates the relationship between the publisher and the subscriber. It's what we call, of course, the subscription. And that's what we are going to discuss today, is what and how can we create publishers, what is and how can we create subscribers, where is the subscriber that we've been certainly using in the past in the past lessons in our examples, but we didn't see it, and how do they communicate one to the other via the subscription. And of course, through everything is how and what advantages brings this concept of back pressure, which means having the subscriber consuming events from the publisher, other than having the publisher push events to the subscriber, which is an important concept in reactive applications. So that's what we are going to discuss today. It's pretty easy. Of course, to discuss it, in my perspective, there is no better way than starting an application. And this time our application will still be a Spring application, because I'm not going to create that kind of a very dummy application. I just want to make you understand things with what we've been already used, because it's not is important is you understand what we discuss here. So I don't want to push you into another environment. That's the idea. So Spring Reactive, I think this is C4 E1. We can use Java 17 because it's the latest, but it doesn't matter. And the only thing that I want to have is an endpoint, a reactive endpoint, and the dependencies that comes with the reactive capability in Spring Boot. So, but I won't actually create a really real endpoint that returns data. As you will see, I'm going to simply create some demonstrative examples, and I'm using this endpoint just to have a way to call that thing that I implement. So is Reactor, is it disposable, the actual subscription in Reactor, is it disposable, the actual, if that means if you can cancel a subscription, the answer is yes. I'm not sure if that's the question, so I'm not sure if I got it correctly, but yes, as you will see, and I don't want to get in details from now because I will take them step by step. If your question is the subscription cancelable, the answer to the question is yes. Thanks for the question, by the way. And let me create a controller, and just because in the past couple of lessons, if I correctly remember, we've used routes. In the first lesson we started with having that kind of controller syntax, and then we've used only routes. Let me just, for the sake of the example, go back to the controller syntax so that I can remind you how it looked like. So I will just create a so-called demo controller, and then you know that you can simply just annotate it with REST controller, and it's still using reactive. I will make it void because I told you this time I'm not going to create a real endpoint, it's just to be able to call something. And then I say here demo, and I think for the moment this is more than enough for our demonstration. So first of all, I'd like to show you how you can create an instance of a Flux or a Mono, and then we will basically add a subscription to it, because what you will learn is that in the previous episodes where we've been using Flux here of whatever that was, product, something else, it was Spring that was creating behind the scenes a subscriber for our publisher. So we were simply just responsible for creating the publisher, but there was somewhere a subscriber, just that we didn't see it. But today we don't focus on the web app anymore, we are focusing on the whole stuff, and I want you to understand what a publisher is, what a subscriber is, what a subscription is, and how do they communicate. So instead, I'm just going to first show you how to create a Flux, and then we are going to discuss about how to subscribe a subscriber to a Flux. So I can say something like, and there are a lot of possibilities. For example, the simplest builder method for a Flux is the just method, where you simply just have to enumerate the values which represent the events in the Flux, in the reactive Flux. Another possibility to create a Flux is from a stream, and it doesn't really matter how you create this stream. It can be a stream that you created out of a collection, or simply directly got it from somewhere. What else can we do? You can have it from an array, you can have it from any kind of a collection. So say if I want to have a Flux created out of a set, I can do that, and so on and so forth. So somehow you create the Flux, and the same is with a Mono. So basically the same is with a Mono, because again, remember what I just said a few minutes ago, a Mono is like a Flux, but it mostly have one element. So it's just the difference between one and many. So the same you can just say, but you can only have a value in the Mono, so you can't enumerate values here, because that's what Mono is. Because both of them represent publishers, let's just take one of the syntaxes and focus on it, because everything else works basically the same. And when I say publisher, If you simply just go inside this, let me try to do that because it seems my IntelliJ is a bit slower today. You will basically see it extends, it's a class, so it implements in the very end this nice interface which is part of the reactive streams package, and this is one of the most important contracts that you that you will learn about a reactor. Can we get it from an enum? Well, I'm not sure you have an enum possibility, but you can always transform an enum into an array, isn't it? So I don't think there is the possibility directly to have it from an enum. I think the flux, that's your question, but you can make it from an array, and since you can always turn an enum into an array, then you can have it from an enum. Yes, it's easy. Cool. I hope I answered your question. So the publisher, that means you can even make it so now this is a flux. If I want to convert that var into the real type, it's a flux of integer, but I could have basically written here simply publisher of integer, and that still works, isn't it? Because any flux is a publisher, so it makes sense. And the flux is one implementation, but the real contract is the publisher, as I was basically drawing earlier when I said we always have a publisher that is the creator of the events, and as you will see, we need to have a subscriber. Now, if I'm going to do anything with this, like I've been doing in the previous lessons, say on next, do on next something, do on next, print in the console the value. The question is this going to work? Will we see anything in the console if we do something like this? So this is my publisher. A do on next method is a method on the publisher that executes something, and that's what you give as a parameter with this consumer for every event in the flux. But if I'm going to run this application, that's precisely what I'm going to do, and execute it, we shall see that we don't basically have anything being executed. And the reason why we don't have anything being executed is the fact that we don't have a subscriber. In the previous lessons, we saw things happening even though we didn't create a subscriber, because it was Spring Boot creating one automatically for us at the moment when we were either returning it from the controller or we registered it as a route. So that's where the magic happened and where a subscription was created for us. But at this moment where everything is just inside of a local block of code, there is no longer anything that Spring Boot can do for us, which means we can't rely on Spring to create a subscriber. So now my app started, and if I'm going to call, let me show you that I'm actually calling this, okay, from a browser. You literally see nothing in the you literally see nothing in the console. Maybe you would have expected to see the numbers 1 to 6 in the console, but that's not happening. And the reason it's not happening is because if you don't have a subscriber, then nobody consumes the values, and then absolutely nothing in terms of the publisher happens either. So you really need to have a subscriber, and to add a subscriber, you can use the subscribe method. And the easiest subscribe method is the one where you simply give a consumer representing the logic in the subscriber, and then you will get a default implementation of a subscriber with that logic being called for every element, for each element. So that means if this is the element, and then I print the element in the console, and if I restart this application, then what I will see in the console is every value twice. Why twice? Because once will be printed by the logic in the subscriber, and the second time the value will be printed from here, from the logic that I gave on the doOnNext method. And the doOnNext method will execute now because I have a subscriber. So somebody subscribed, I have a subscriber consuming the values, and everything from the publisher itself throughout its entire pipeline and up to the subscriber will now execute. So doing the same thing, going in my browser, calling the endpoint, will show you in the console every value twice. Once being the case where it was printed by the doOnNext, and the second one when it was printed by the subscriber itself. So now I think we do agree and everybody understood that having a subscriber is mandatory. If you don't have a subscriber, nobody consumes it. But let's go even deeper in our discussion. So what is actually this subscriber? This subscriber, and I'm now going to use again the contract that is the one, again, after the publisher, the second contract of the basic contracts of reactive applications that we need to discuss. So just to simplify it, let's just have the simplest syntax, which is publisher, subscriber. So the simplest is you have a publisher and the subscriber. And as you will see, in between you can have multiple, such as doOnNext, multiple things that happen on the pipeline. But I'm not going to discuss those today. Today, let's just focus on the relationship between the publisher and the subscriber. So the simplest syntax you can write to have something working is having a publisher, whichever that publisher is. It can be a Flux, it can be a Mono, or it can even be a custom publisher that you can create. And I will show you that you can create your own custom publisher if you'd like. You will usually not do that. You will most likely use Mono or Flux. So I'm not going to spend a lot of time discussing details as how to create your custom publisher, because it's not something that I believe you will find often in real world applications. But I want you to know that you can do that. And then of course you need to have the subscriber. So now if I'm running the same thing, you will just see every number in the Flux one time because it's simply the subscriber that I gave here. Basically, I gave the logic, not the subscriber here, just the logic, and the subscriber was created. It's subscribed to the F1 Flux, which is my publisher, and will show me every value. So let me call it again. And you can see now, indeed, every value is only displayed once. Cool. So now, being that we have understood the two main contracts and the relationship between, let's actually see here the exact subscriber, because now I only gave the logic, but in many cases it's not enough to just provide the consumer and tell what should happen with the values. You might want to have a custom subscriber, and let's prove how a custom subscriber looks like and what can you do with it, and this way we will go one step further into the box. So you can say I want a subscriber, and the subscriber is the interface that is again still part of the reactive streams, same as the publisher, and the subscriber has the four methods that you can see here. One of them is the onSubscribe, which gets as a parameter the subscription. Now we see even the third very important contract in the reactive applications. On my diagram here, the subscription. You will see that the subscription is basically the link between the publisher and the subscriber. So the onSubscribe, this is a very important method that the subscriber has, because it's the method that is used by the subscriber to get a subscription from the publisher, and through the subscription communicate with the publisher. And yes, you heard it right, it's communicate, the subscriber communicates with the publisher. is because the subscriber asks values from the publisher, not the other way around. So it's not the publisher that pushes value into a subscriber, but as you will see, it's the subscriber that requests values through the subscription from the publisher. And again, remember, this is a very important thing. This is a thing to remember, because this is, again, what we will see. It's the definition of an important concept named back pressure. It has an onNext method that, as you will see, is called by the publisher when the subscriber requests values. And the value, the T value, is basically the value that the publisher will provide to the subscriber upon its request. We have an onError method that gets a throwable that the publisher will request, will call in case an exception happens. Be very attentive on its side. That's a very important thing. So onError is called by the subscriber if an exception happens on its side, is the way the publisher notifies the subscriber that something happened. And the onComplete, which is the way in which the publisher notifies the subscriber that it has no more values, that everything ended. So now what you can do is definitely implement the 4 methods. And the easiest way to implement the 4 methods, well, we can for the moment just see what happens when we create our subscriber and which are the methods that are called. Say subscribed, say onNext, and let's say we print the value, say onError, and let's say we print the throwable, and say onComplete. Okay, if I'm simply just leaving it the way it is, the only thing that I will see is the subscribed. And the reason, and let me prove it to you, so let me restart the application and call the endpoint to see what happens. And the reason is my subscriber automatically subscribes just because of the subscribe method being called with it as a parameter. So when I call the subscribe method of a publisher, the thing that happens is that for that instance that I gave as a parameter as a subscriber, the onSubscribe method will be called and the publisher will give the subscriber a subscription. But again, remember that in order to get any value, so when I do that, go into the console, we see the subscribe but no value, okay? Because in order to get any value, the subscriber has to request the value. And how does the subscriber request the value? Through the subscription. The subscription is like basically like when you have a subscription to something, and through the subscription you can request whatever service you have subscribed for. So you go to the gym, you pay for a subscription, and say that that's a monthly subscription, and now you have the subscription proof, and you can go to the gym. You can benefit from the service. The same thing here. So the subscriber subscribed to the publisher. The publisher gave the subscriber a subscription, and now the subscriber can say, give me one value. Of course, as you will see later, the subscriber can say, give me as many values as the subscriber wants, so it's not necessarily one. But in my case, this one as a parameter means the subscriber requests one value from the publisher through the subscription. And again, going back to my diagram, remember the subscription is the link between the subscriber and the publisher. So the subscriber subscribes, gets a subscription, and through the subscription requests values from the publisher. And now that I only added this line, obviously what will happen is that after I will see subscribed in the console, I will also see the first value. But that's everything that I will see. I will only see one value. Why? Because only one value has been requested. So remember, the publisher doesn't push any value to the subscriber. It's always the other way around. Okay, so we see indeed the first value has been provided. To provide the value, the publisher calls the onNext method. So the first value in the list, in the flux here, which is in the list of 6 elements, has been provided, and then nothing else happened. The flux didn't complete because it still has values, but the publisher didn't push anything to the subscriber because, well, the subscriber didn't ask for it. And again, I'm saying it a million times, a very important thing in reactive applications is that always the subscriber has to request. If the subscriber doesn't request, it doesn't receive. So it's a very big difference between, many people, for example, confuse the concept of a stream API in Java. That stream API that has been there since Java 8 with Flux and reactive streams. But it's a very big difference between them. One of the biggest differences being even the fact that in that case is the value being pushed instead of requested, which is the case of what we discussed here. Now, if I want, for example, to get a second value, I really need to make sure that the subscriber requests it. So what can I do? I can call the request method after, for example, finishing to process the one that I got. And of course, for that, I need to have the subscription. But we always know that the subscription will be provided only once when the subscriber subscribes to the publisher. So that means that I can simply take it out here. Then I can make sure I have it throughout all the behavior of the subscriber. And now I will start by requesting one element the first time. And then every time I process one element, I do request for another one. And if I'm now restarting this, what you will see is the full execution of my stream. Okay. One more time, it wasn't started already. So I'm going to call the demo method. And now you see, subscribed. Oh, it actually, the browser called it multiple times. Let me clear and make it only once to make sure that it's everything clear. Cool. So you can see the subscribe, and then you can see that all the elements one by one have been requested. And then at the very end, the publisher called the onComplete method, because that's the way in which the publisher tells the subscriber that it has no longer any more values. So its values finished. It provided everything it had. There is nothing more to request. It's pretty easy. And now you don't need to necessarily have request only one element at a time. So what you can do is request multiple elements at a time. So for example, you can have 2 elements, and then once 2 have been consumed, ask for 2 more. It is on the decision of the subscriber how many elements and when the elements need to be delivered. And that's what we call back pressure. So back pressure is the subscriber in its own pace ask for elements from the publisher, like in this case, instead of having the values given by the publisher without it requesting them. So a question is, what happens when we pass the consumer? I'm not sure what that means. What is pass the consumer? How subscriber requests for all values in the stream? Please rephrase it. I don't understand either of the questions. Sorry. So I'm not sure I get the question. So we have a subscriber. When it subscribes, automatically the publisher request calls the onSubscribe method. Then inside the onSubscribe method, the subscriber requests for one value. The publisher calls the onNext method. That's always happening after a request. The publisher will call one or multiple times the onNext method, depending on how many values have been requested. So now I requested only one, so onNext will be called only once. And then at the end of the method, another request is made, and then the publisher will call the onNext again, and then another request is made, and then the publisher will call the onNext again. Basically, the publisher will always call the onNext method after every request until the end. And when it has no more values, then the publisher will not call the onNext anymore. It will simply call the onComplete, that way telling the subscriber that there are no more values. Of course, I never recommend you put things in code like this. They are very difficult to understand if you put them like this. I do recommend you extract all the logic into separate classes. Like, for example, let's create our subscribers package here and create our, let's call it demo subscriber class. This implements, of course, the subscriber. In our case, it's a subscriber of integer values. I will just copy all the logic from here, so I don't change anything, just copying the logic. The only thing I did is to simply move them into a separate class for making our code cleaner. And now, of course, I can say new demo subscriber. So now it's, if I'm rerunning the app, you will see the same thing, but the subscriber is just my instance of a subscriber that is very, very simple here. So if I'm calling now, you will see the same thing, and that's the values followed by the onComplete. So basically, we discussed all four methods. From all the four methods, we discussed three of them: the onSubscribe, the onNext, and the onComplete. Let's see also the fourth one, and that way we complete the definition of this contract. So in the subscribe method, you pass the consumer and all the values printed on console. My question is, how the subscription take place in case we pass the consumer? I'm sorry, Shivam, I'm still not understanding the question. So on the method, the subscribe method, which is a method that's part of the publisher, we will discuss it later. When you call the subscribe method with this instance, automatically F1, which is in our case the publisher, will call from this instance the onSubscribe method. That's happening behind the scenes. That's happening from the implementation of the publisher. When you call that, and you can make it on a diagram. So say this is the time arrow of the publisher. So let's say this is a time arrow of the publisher. This is our Flux F1 in this case. And say you have a different time arrow of the subscriber. Both of them are two object instances, okay? When the subscriber calls, when the Flux calls the subscribe method, it's basically the subscriber being subscribed. Okay, so this is the first step. Is I put it here, F1 subscribe of S, where you can imagine S is our subscriber. The next thing that happens is Flux will call the onSubscribe method of the subscriber. So that happens from here, from the subscribe method. OnSubscribe, and that provides a subscription. The subscription is the key of the communication between the Flux and the subscriber, because now, using the subscription, the subscriber can say, hey Flux, give me one value, or give me 10 values, give me how many values the subscriber wants. So through the subscription that has been received, the subscribers say sub request one value, that is this request here. And what happens every time when the subscriber requests a value, one and more times, depending on the value here, if the value is 1, it will be 1 time. But if the value is larger than as many times as requested, it will say on next, providing here whatever value needs to be provided. So again, this is only once in the case you say 1, but if you would have requested 2, then the publisher will call the subscriber on next method 2 times. So it basically, the request is just a query from the subscriber, please give me n values, and then the publisher gives the subscriber n values. And at some point, then this happens now as many times as you want. So the subscriber can ask for some other values, and the publisher will provide the values up to the point where there are no more values. And then when there are no more values, the publisher will just say on complete. And on complete, it means that the publisher doesn't have any more values. You can see here that the publisher always has access to the subscriber, because the reference to the subscriber has been provided from the very beginning, but the subscriber doesn't have access to the publisher. In order to communicate with the publisher, it always uses the subscription. The subscription is always provided by the publisher to the subscriber immediately after the first step, which is the request for subscription. This is the request for subscription. Then a subscription is provided, and then the subscriber starts requesting as many values as they need. The publisher provides values after them being requested, and this can continue up to the point where no more values, where the publisher has no more values. Of course, there is also the case, and that was what I wanted to now tell you, the case where an exception happens on the publisher side, and then instead of having the onComplete method called, the method that will be called is the onError, and I'm going to prove it to you now. So more questions. Since this is not a stream and I'm not able to collect how this will work, then I try to merge two fluxes. I will discuss this, Emil, in the next lesson most likely, because we will need to discuss, and I think there are more than 50 methods in the flux itself. So if you do something like this, we will discuss plenty of these methods. You can even collect the values. I'm going to discuss this, but wait a bit for it, because I don't want to discuss the methods, the behavior of a publisher until people understand how this stuff works with the publisher and the subscriber. So in a few lessons, you will have not all the methods, but all the relevant methods. I will go through them, and I will discuss how you merge two fluxes, how you treat exceptions, how you collect values, if you should or not use blocking methods. That's stuff that we're going to discuss, but not today. After onComplete is called, the subscription is closed, or subscriber can use it again to request. That's a good question. To be honest with you, I don't know in case of Flux, but I would say that it shouldn't be usable anymore. So it doesn't make sense for me, Julian, to be usable anymore. Now, all the implementations I've made, I never made a publisher to be able to give a subscription that is reusable. And for me, it makes sense to be like this. So I would say no, and don't implement any kind of an architecture where you have reusable subscriptions, because you will add some complexity that might be difficult then to manage. Good. What I wanted to show you here, and that's to cover everything from the subscriber, because now I think it's clear how it works. I want to cover the onError as well. And the first thing I'd like to cover is the fact that the onError is called by the publisher when an error happens on the publisher side. And one of the things that are misunderstood here, in my experience, is people considering that if they throw an exception here, you will see the onError message, which is not the case. Why is it not the case? Because if you throw an exception here, you are inside the subscriber. The subscriber has to manage its own exceptions. This method is especially made for the publisher to call the subscriber if something happened on their side, on the publisher's side. So if I'm running this now, you will basically see that this message is not displayed because there was no exception on the publisher side. The exception happens, but it happens in the onNext method, which is in the subscriber side. So if I'm going to call the endpoint, I see the first 3. When the value reached 3, the exception was thrown, but since I didn't catch it here and I didn't manage it here on the subscriber side, you don't see anything else. So if you were expecting to get this method called, then that's not the case. But when is this method called? For any exception on the publisher side. So I'm going to take the exception out from here, and instead I'm going to put it in the pipeline on the subscriber. And I will say do on next throw new runtime exception. So this is something that happens on the publisher side now. Guess what will happen when I'm running the application and calling the endpoint? Well, because this exception happens on the publisher side, the publisher will now notify the subscriber that something happened via the onError method. So if I'm calling this now, you will see that the onError method has been indeed executed. So what the onError method is a way to allow the publisher notify the subscriber if any exception happened on their side. The onComplete method is a way the publisher can notify that there are no longer elements, no longer events to be sent. The onSubscribe method is the first method that the publisher will call upon the subscribe request and will provide a subscription, which, as you've seen, is the relationship, it's the way the subscriber can use the publisher service. Because in case of a reactive stream, it's always the subscriber requesting values. If the subscriber and we start with doesn't request values, then it doesn't receive values. The publisher only gives the subscriber as many values as the subscriber requested, and will only give them values if they requested it. So it's like, for example, when you go eat at your mother or your grandmother, then you will have to eat everything. Nevertheless, if you can't eat any dessert anymore, you say I don't want any dessert, and then your mom say no, you have to eat it. That's not back pressure. Okay, that's no back pressure. That's how a normal stream works. Back pressure is like when you are in the restaurant, you ask the waiter for something, and then they will give you that something, and then if you are still hungry, you can ask again for something else. That's back pressure. Exactly like in this case. The subscriber asks for something, and only when they request, they get as many as they requested. That's a very important concept. We call back pressure. Okay? Whenever you hear about this term, it means the subscriber asks for values. Is not forced into values. If the flux is flux just 1, 2, new runtime exception 3, then onError method will be called. That's not possible because you would need a flux of objects, isn't it? So no, the answer is, first of all, if you really want something like that, then integer here can no longer be the case. If you want to have something like 1 new runtime exception 6, then here you would need to have object, and then still the onError method will not be called, because in this case runtime exception is just an event. So the event itself is just a value. The onError method happens when an exception is thrown. So you have to throw the exception. If you don't have a throw keyword to throw the exception somewhere in the publisher side, then no, the onError will not be called. So in this case, even though you created a flux of objects which includes an object of type runtime exception, it will not trigger the onError method, because it's just an event of type runtime exception. It's no exception thrown. Is onSubscribe blocking or non-blocking? Unsubscribe doesn't classify either on blocking or non-blocking. Unsubscribe is just the place where the subscriber is linked to the publisher. Everything else classifies as blocking or non-blocking. So the blocking or non-blocking is where basically where you have everything in the publisher before you have a subscriber. For example, in this case, if I call a method with, say, block first, which will not work in this case anyway because it will give me an exception if I'm in a controller. So you are a little bit beyond the discussion. Let's stick to what did we discuss here. For the moment, just understand the relationship between a subscriber and the publisher. Can we define a global exception handler? Yes, you can define a global exception handler, and I think we have something like discuss something this way in the previous lesson. So I invite you to go to the previous lesson and see if you can find your answer there. Otherwise, it would be a little bit more difficult to provide you the answer in 5 minutes. Last lesson we discussed about exceptions. Cool. So now again, sticking on our discussion, which is relationship between subscriber and publisher. Make sure you understand it. If you don't understand this, don't try to go further thinking about methods on the pipeline itself, and so on and so forth, because it doesn't make sense, trust me. To understand reactive applications, you need to understand them from the very beginning, from the very foundation. And this is the very foundation. So we've discussed everything on the subscriber. And in case of the subscription, one of the earlier questions was, can we cancel a subscription? And I said yes. And in case you want to do that, a subscriber can always call the cancel method to cancel a subscription. Once they've canceled the subscription, they cannot request values from the publisher anymore. So the subscription contract only has two methods. The request, you've already seen, is the way in which the subscriber can ask for one or more values to be delivered, and cancel, that allows a subscriber to cancel a subscription, and that of course will not give them anymore the opportunity to request for values from that publisher since they canceled their subscription. I wanted to also do one more thing today, but I won't have the time, so I will leave it for the next time. I wanted to also create a custom publisher. Even though in most cases using Mono and Flux is what you will be doing, and that's why in the next lessons we will focus on all these kind of methods that you will get as part of Flux or Mono, and there are many methods. We won't discuss all of them. We will only discuss a few that are most used in real-world apps. But I want first, before going into those methods, to also show you what a custom publisher is. So maybe next time we start by not only implementing a custom subscriber, but implementing everything from the publisher to the subscriber. So instead of me, as I did today, using Flux or Mono, next time I want to implement the publisher also. So you will have a custom publisher and the custom a custom publisher, a custom subscription if needed, and the custom subscriber. So everything custom, just based on the contracts. And if you understood how to do that, then it means you really know the foundation of what reactive applications are. And then what we will do next is discuss the methods on the publisher's pipeline. So that's the plan for the next lessons. If everything has been covered, but at least what I wanted to do today without this part of the publisher that I will move for later. Thank you very much for all the questions. I hope that you enjoyed this lesson as well. I'm looking forward to your questions still. and let's meet next time to discuss more things about reactive applications and how to build them. Thank you everyone, waving goodbye, cheers!